Hello students. Today we are going to see a chapter called as Atoms and Molecules from 9th Cbse, chapter number 3. It's a very interesting chapter which talks about atoms and molecules. If you see in ancient India and also in the Greek philosophers, they have always wondered the unknown and the unseen form of matter. As you all see, matter is all around us. You see matter as such, and we don't have the idea what is matter is all about. Then the idea of divisibility of the matter was considered long back in India, around about 500 years BC. Indian philosophers they postulated that dividing the matter, that is called as padarth in Hindi. Okay, we shall get smaller and smaller particles as such. Ultimately, a stage will come where you will see that, where you will see the smallest particles beyond which, suppose if this is a matter here, if this is a matter, if we divide this matter, if we go on dividing this matter further, you'll see that we can divide it. But a stage will come where this cannot be divided. Okay, further. Okay, that is the smallest particle which further division will not be possible. And that's the reason it was named as Parmanu. That is the smallest particle. Then also in what we see in the same era, the Greek philosophers they also suggested that if we go on dividing the matter, a stage will come when a particle obtains cannot be divided further. Okay, the same lines what we are talking about of the Parmanu. And therefore, this indivisible particle, okay, that is the atoms. Okay, that is the smallest particle we are talking about. Right. Then let's go further. Antonio Levisseur, he also laid the foundation of chemical science by establishing two important laws of chemical combinations. Right, these laws are very important for us to understand what these laws is all about. Let's see these laws in detail. The laws of chemical combination. When we see what we understand by a chemical combination, right? For example, if we want to prepare a tea, what we do? If we want to prepare a tea, we take milk, then we take sugar, water, and tea leaves, and then we get the tea. Means what? That is, we are having a chemical reaction which is happening. Right? Okay. So, in a chemical reaction, what we see is that we have got a reactant and we have got the product. Right? So, here, would like to see that what will happen with the mass, okay, of the reactant and the product, right? Is this mass the same or the mass different that we want to see, right? Okay, let's try to prove this. For this, what we are going to do, we are going to take, or we are going to prepare solutions of copper sulfate and sodium carbonate, respectively, right? Okay, such as X and Y. We are going to prepare X and Y we are going to take, right? So copper sulfate, we are going to prepare 5% of solution of copper sulfate and sodium carbonate, 10 ml each in water we are going to do it. Okay. What we are going to do is that we are going to take a little amount of solution of Y, right? That is my sodium carbonate, okay, in a conical flask and some solution of X in an ignition tube, right? Okay, so ignition tube and uh, flask, we are going to take the solutions respectively. Okay, so we are going to take here copper sulfate, and we are going to take what? Sodium carbonate. All right. Okay, so we have taken this, and this is the apparatus whole as such. We are going to use it. What we are seeing here is that we have got conical flask, then we have got the ignition tube, which has been suspended by using a thread upside. And if you see carefully, you'll see that this has been separated, the ignition tube and the solution inside here, X and Y, has been separated. Why? Because there is no reaction happening between them. That's the reason this apparatus is being prepared like this. Okay, now what we need to do? We need to weigh this. Okay, suppose the weight of this apparatus is 300 grams. Okay, now keep this weight with us. Right. Then next what we need to do? We need to go for the reaction. Right. Okay, let's see what we are going to do here. Okay. Now, what we are doing is we are now tilting this, okay, apparatus in such a way that this ignition tube, okay, and the solution in the conical flask, they mix together. Okay, so now they should mix together, right, in such a way that a chemical reaction happens, right? Okay, so the chemical reaction will happen, and what will happen? A new product will be formed, right? A new product will be formed. So now we need to check again the weight, right? The weight of this whole apparatus. Now, if you check the weight of this apparatus, it will be 300 grams. Now, when the reactants were there, and now after the reaction, the products are there, what a difference what we see? We see that the total mass of the reactants and the products, okay, after the reaction, the total mass of the product also remains the same. All right. Here are the few of the questions what we are going to see. Weigh the flask with its contents carefully. We have done that. Now tilt and swirl the flask so that the X and Y get mixed. We have done that. Then we have weighed it again. That also we have done. Then what happens in the reaction in the flask? So reaction happens. The reaction is very clear. The reaction happens as copper sulfate plus sodium carbonate, right? That will gives me what? Copper carbonate plus sodium sulfate. So this reaction I'm getting. Okay. So you'll see that new products are being formed. What happens in this reaction? We see that in this reaction here, the copper sulfate reacts with sodium carbonate and a precipitation reaction happens which produces copper carbonate and sodium sulfate. All right. Okay. Let's try to answer a few of the questions as such. Do you think that a chemical reaction has happened? Yes or no? Yes, the chemical reaction has happened. Here is the proof. The chemical reaction has happened. Right. And if you see the color of copper sulfate, which is blue in color, that color is lost. So we can say that a chemical reaction has happened. Why should we put a cork on the mouth of the flask? Right. Now see this. We have put a cork here. Okay. Why we have put it? Just to prevent any loss of mass, right, in the form of gas or liquid. So that's the reason you have put a cork, right? Then does the mass of the flask and its content change? No, it remains the same. So it proves that it proves the conservation of mass in this case. Now, some few of the questions are there on page number 27 NCRT textbook. Let's try to address them. Okay, so see the question is, in a reaction, 5.3 grams of sodium carbonate reacted with 6 grams of acetic acid. The products were 2.2 grams of carbon dioxide, zero point 0.9 grams of water, and 8.2 grams of sodium acetate. So that these observations are in agreement with the law of conservation of mass. So what we need to do, we need to write down the reactants on one side and we need to write down the products on another side. Okay, so what are the reactions? What they are saying? 5.3 grams of sodium carbonate. So sodium carbonate I have taken here. Okay, 5.3 grams I have written. Then that reacts with 6 grams of acetic acid. So acetic acid 6 grams also we have taken. Then we need to sum up these two. 5.3 plus 6, it gives me 11.3 grams. Right. Then what products I get? I get 2.2 grams of carbon dioxide, zero point 0.9 grams of water, and 8.2 grams of sodium acetate. Okay, so what I need to do? I need to sum of these same. If you see that the mass of the reactant is equal to the mass of the product. So these proves, and it is with the agreement of the law of conservation of mass. Okay, so yeah, here what you see that any reaction can be given to you, and in that what they will give you the respective mass of the individual reactants, and what you need to do, you need to just sum up those, and you need to sum up the mass of the product also. Let's see the next question. Here you see that hydrogen and oxygen combine in the ratio of 1 raised to 8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas? Right. So, what has been given? It is given that the ratio of hydrogen and oxygen by mass to form water is 1 raised to 8. Then the mass of oxygen gas required to react completely with 1 gram of hydrogen gas is 8 grams. Therefore, what we see is that the mass of oxygen gas required to react completely with 3 grams of hydrogen will be how much? It will be 8 into 3, that is 24 grams. Students will continue with this in the next section. I hope you have understood the concept of law of conservation of mass. Also, you have understood what is matter all about. So if you like this topic, kindly subscribe and share so that all the other students can also be beneficial.